Hey, welcome back. This is one of the funnest geometries of them all, and that is four repulsions. In fact, in this course, we won't go beyond four. But what's an example of a molecule with four repulsions? Something like CH4, which is methane, would fit the bill nicely. In fact, it's got all those single bonds around there. Remember, hydrogen doesn't need an octet, right? It just needs 2 electrons. So this is a valid Lewis structure. And if we count the repulsions right, any bond, right, counts as 1 repulsion. So we've got 4 things to try there. So let's go ahead and see what 4 repulsions look like. Okay, so we're back in our PhET website. So I can kind of put those 4 bonds on. So there's 1, there's 2, right? So that's that linear geometry. And there are 3, so that's our trigonoplanar geometry. There we go. So isn't that beautiful? In fact, that one kind of looks like it's sticking up in the air at us. The convention is to kind of move it so that 2 of the bonds are laying flat on the page. And when you do that, one of them is kind of coming towards you, this one here, and one of them is going away from you, this one here. So we'll get into drawing that here in a second, but let me just show you the bond angles. Those bond angles are all 109.5 degrees, and the electron geometry is called tetrahedral, and the molecular geometry is exactly the same. So let me go through how to draw these with you now. Okay, let's try our hand at drawing that tetrahedral shape. So the molecule itself, the way we're going to draw it, so imagine we've got a center atom and we've got 4 electron pairs around it. Okay, so I'm not going to specify exactly what it is, but there's 1, there's 2, there's 3, there's 4. So we've got that tetrahedral geometry, and 2 of the bonds lay flat along the page. So we're going to go ahead and draw it like that. And then one of the bonds actually comes out of the page towards you. We're actually going to use a wedge here. So just like if you hold your hand in front of you and bring it closer to your eyes, your hand gets bigger. So the edge of the wedge there is showing that the atoms are coming towards you. I guess I could put those lone pairs in here, here, and here. And then the 4th one was going away from you. So we actually go ahead and draw a dotted or a dashed line here just to represent it kind of receding into the background. So here's an image from the textbook here. So we can see that these bonds here lay flat on the page, and this one here is coming out, hence the wedge, and this one here is going behind, so hence the dashed line there. So that's how we're going to draw it. So if we had methane, right, what we would do is we would take methane, right, so its Lewis structure is kind of boring looking, right? In fact, its Lewis structure looks like everything's at 90 degrees, but if we went ahead and we applied VSEPR to it, okay, so valence shell electron pair repulsion, those 4 bonds, right, would repel and take that 109.5 degree angle. So let's go ahead and write that on there. So 109.5 degrees. All those angles are exactly the same. And that geometry is called tetrahedral. And it literally comes from the fact that there is a solid, a 4-sided shape called the tetrahedron, and it looks something like this here. So if you ever play Dungeons and Dragons and you need to roll a 4-sided dice, you're rolling a tetrahedrally shaped dice, or die, I suppose.